no problem. We'll just go to that.
Check. This is on. Yeah, go with that. I think that's fine. So anyhow, let's get away from that. Let's get back to these arrays. Let's see. Okay, so that's off. Yeah, mute that. Back here. Okay. Check, check.
Executive here at the Institute of Physics, for those who don't know me. Nice to see a number of familiar faces, but also nice to see so many new people visiting us for the first time. So welcome to the Institute. I have a bit of formality to do to tell you that we're not testing any fire alarms while you're with us today. So if you do hear the fire alarm, there are 2 exits out of the building. Through either doors, there are staircases that go up and out onto the street either side. And if in both cases you turn this way and gather by the Tesco's building, that's the assembly point. The other thing I'd like to say is please keep your mobile phones on, but if you could turn them onto silent, that would be great. There is a hashtag for today, IOP LiFi. Did I sound like I knew what I was talking about then with the hashtag? Because I'm trying to be down with the kids. But please do tweet through the session if you want, hashtag IOP LiFi. Happy International Day of Light. The reason we're holding the meeting today, it is the International Day of Light. The Institute of Physics was a founder of the Year of Light a few years ago with partners in Europe and the US. So after 5 years, we persuaded the UN to have a Year of Light. And I can tell you firsthand, it's much, much harder to persuade them to have a Day of Light because you only have 1 year of light, but you have a Day of Light every year. So we were delighted when they instigated the Day of Light. So every day now, on the 16th of May, we will celebrate light and all it does for humankind. We couldn't miss the opportunity to show you some of the technology that's on display here in the Institute. There are 12 projects that connect the building, businesses, universities and schools in the Institute. And one of those is on show today. That's the LiFi technology. I'm really delighted that pureLiFi, who provided us with the technology, are here to talk about it and exhibiting things. I should also welcome those joining us on the live stream. We're webcasting this. And those on the live stream, just an encouragement for later, if you do tweet on the hashtag with your questions, we'll have a Q&A session afterwards with the pureLiFi team on the stage. So we'll be able to pick up the outside questions as well as those in the auditorium. For those who are not familiar, and I see a number of people who are perhaps not in the membership, you may not know as much about our member program, but I just wanted to tell you a sentence about those things related to business, because that connects with our activities for today. We have a business innovation and growth group. It's free to join for those people and businesses who are interested in that. It's a group of large, small companies who come together to talk about issues that they commonly face and to network and to look at related technology opportunities. We also have an affordable workspace, an incubator center upstairs, and there'll be a chance for you to have a look at that if you're interested in making use of that. And we have a series of business briefings that we run, trying to unpick technology for non-technology specialists, and also the support services that go around startup businesses. And we have a business awards and innovation awards. Now, I'm looking at Anne. Theoretically, they close on Friday, but I heard a suspicious rumor that we might be extending it for a week or so. So if you are interested in the Business Innovation Awards, where we hold the award ceremonies in the House of Commons in the autumn, if you're interested in entering those, thanks to Anne, you've now got an extra week to think about that. But let me turn to the focus of today, because today is about one of our Business and Innovation Award winners in 2017, and that's pureLiFi. And I'm particularly pleased that we have Professor Harold Haas, who's going to present to you today on the technology, the LiFi technology. Let me tell you a little bit about Harold before I pass on to him. So Harold's been working on this for some time. My notes say 2003, but I suspect there was some ideas seeded well before then with Mustafa Afghani, both at the University of Edinburgh. They spun that technology out into pureLiFi in 2011. Harold gave a famous TED talk, and if you haven't seen it and you want to pick that up from the TED series, I'd encourage you to do that. It was after that TED talk he got christened the father of LiFi. So Harold, no pressure. He's going to explain the technology, so I don't have to do that. But I just wanted to close by my introduction by saying just recently was elected as a Fellow of the Royal Society of Edinburgh. He's received a number of prestigious awards for his work in this field. And Time magazine quoted it as the top 50 in best inventions. So, Harold, you're going to tell us about this in some detail. Over to you.
Thank you, Paul. Yes, good afternoon, ladies and gentlemen. Thank you for the kind introduction, Paul. I hope I can show you a little bit of our journey in our work on light communication today. And actually, I'm delighted, emphasis on light, to be here in this wonderful new building at the International Year of Light to talk about light. So I hope with that, I take you through this little journey. So what we try to do with light is to do what we do in fiber optics, take it to the communication space. So you want to, not the wired communication, so the wireless communication space. And I'd like to start with a well-known physicist that many of you know, and great minds, and I'm always surprised how many great minds in the past were there. They predicted the future in a quite exact way. I mean, he says if wireless is perfectly applied, the whole Earth will be converted into a huge brain. And that may ring a bell when you hear about machine learning, artificial intelligence. We are turning the world with the fourth industrial revolution into a large brain. But what many people who work on AI and machine learning don't appreciate sometimes, you need to connect the brain to your arms and to your legs. A brain alone does nothing. You need the nervous system. You need the nerve tracks that connect the server to the autonomous car. And this is where my talk is sort of hinged on and sort of centered around the nervous system. So what we see is the nervous system. What we want to do is, this is part of a world we see now. We have already the big spine running through our cities and through our continents with fiber optic communication. But the photons that go through these fibers are in cages at the moment, but we want to take the photons out of the cage and take them into space. And that is sort of a city that you see here. You may see a city of lots of lights. I see the nervous system of the future here that turns this into the smartest city this planet has ever seen. And for that, we have worked on LiFi. So in taking it further, I mean, you see that here in the IOP, we have our LiFi units installed in the public space. You see the lights, but there is more than the lights. We have an unprecedented infrastructure of of lights on our planet already. They are connected to the power, to mains power. So there is a network already there that we can use. And what we also have is we can turn this into a light. We can put in storage, memory cards. We can put into the light, we can put in a computer, an operational system. And actually, the lights that you see up there, they have all of this integrated. Storage, computing, and it has sort of connectivity back to the internet. So that actually is a node, a neuron of the neural network we are building. And the light that comes out, this forms the nerve tracks to connect our things and our devices. And in a modern world where we see a lot of anxiety around security and cybersecurity, we also want to transmit to the end host in a secure manner to avoid eavesdropping and interception. And LiFi, and I'll show you later, has these wonderful properties to allow cyber-secure wireless communication systems. So yeah, that is the last bit. That is basically AI, machine learning, the computational capacity. All of these things are in a current light bulb and therefore usable. So I talked about the capability of turning a light bulb into a sort of a neural node. But now I'll talk to you a little bit about the nervous system. So basically, the number of impulses that run through this nervous system, or in other words, the number of data packets. And the question has always been, and I mean, we as an engineer always think about how much data do we actually need, how much capacity in 5G and 6G do we need, and that is a question that we try to address. And if you see here with the background, the main drivers behind data usage is behavioral changes. So 20 years ago, if you go to a concert, no one would have picked out a smartphone, but now you see everybody taking smartphones, taking pictures and sending them to the iCloud or whatever. So here's a little bit of an overview in terms of how we use data. And I'd like to distinguish in basically two classes that you see here. One is the classic interhuman communication, so the social networking, human-to-human communication, so it's the average internet used by a person. And then we have the things, the autonomous cars, the planes, and also in the future, Industry 4.0, the smart cities. And you see already from human users of 1 gigabyte to 1 or 4 terabyte in autonomous vehicles. So you have an increase of 3 orders of magnitude, moving from from human-type communication to machine-type communication. And now the future smart industry, the smart cities, you have another 3 orders of magnitude. So jumping from 1 gigabyte per person to petabyte, these are 6 orders of magnitude increase. And these are really huge numbers. And if you want to run a smart factory, you've got to supply the data to your machine, to your robots, and vice versa. So there's no question around the fact that we will need to send more data through our networks. In fact, there's very nice scientific studies, but also Cisco have been publishing white papers for the last 10 years. The quintessence is, you don't have to read 1,000 papers. The quintessence is here. Mobile data traffic has increased 60% every year, and that's an exponential growth. But primarily driven by humans. Now, what we have is, we not only have 8 billion people on the planet, we will have billions of things, of cars. And it's forecast that we will have about 30 billion connected devices in 2022. And we will have, most of this traffic is actually video traffic running through these networks. And that is where we see that growth sort of unfolding. I think we can all provide these capacities in fiber optic networks, but in the wireless domain, at the moment, we are primarily limited to radio spectrum. It's a particular part of the electromagnetic spectrum. And we have to appreciate, and that is what Maxwell's great work has shown, that light is part of the electromagnetic spectrum. In fact, if we look at the spectrum, the visible light is 1,000 times larger than the entire radio spectrum. So we have about 300 gigahertz of spectrum in the radio domain. We have 3 terahertz of spectrum in the visible light domain. A factor 1,000. It's the same part of the same family of electromagnetic waves. So maybe also to express that a little bit in terms of a communication context, if radio is a single track lane through the highlands, then LiFi will provide 1,000 lanes through the big city of London. If there's a road that has 1,000 lanes, but I doubt it's yet the case. But imagine you have a road that has 1,000 lanes, and that is what LiFi can provide. And by the way, it's not regulated. Every one of us can use it. We don't have to pay thousands and millions of fees. Hopefully no one from government is here to harness the licensing and the auctioning deal. So this is free spectrum, and in fact, it's safe as well, because light is so important, and that's why I'm delighted to have the Day of Light, because it has created life on the planet. And here we use it very and carefully for data communication. So what it does is, you take your smartphone, it's only an example of a mobile device. We will see different devices in the future, but what it does is it receives data from a light source, but also transmits data. It's one of the misconceptions that people say, yeah, what about the uplink? Yes, we can have the infrared spectrum for the uplink. We don't want to see light coming out of our phones, so we can use infrared and use light in the downlink when we have lighting systems around us. So it's bidirectional. And also, you don't have to point your phone when you communicate into the light and try to desperately find the light in order to be able to communicate. It will also work when you turn your phone around. It won't work probably if you have it in your pocket. But we're not saying we don't want you to use radio anymore. Radio has its life on the planet, and it will still have its life, and it will still grow, but we will add this additional capability. So it's bidirectional, but that's not the end, because that could also be defined as visible light communication. What LiFi really defines is the networking aspect. So imagine you have a bidirectional communication link to your device, and then you are sitting around a table here, and then you have one light source, and you don't want to be greedy in taking the light from the other people, so you want to share it. So this multi-user access is also capable or possible with LiFi. And then if you have your phone here and you start your Skype call, and you move from this corner to this corner, you don't want to re-initiate your Skype call all the time when you move out of the coverage of one light. It should be seamlessly handed over. And that seamless handover, that is also possible with LiFi. So it's like a normal mobile communications device. It behaves the same way, except it uses light waves to transmit and receive. And therefore, I need to warn you, there is some confusion out in social media where people say visible light communication and LiFi in the same space, in the same context. But I want to make sure that, like we understand the difference between Bluetooth in radio, it's an interconnection between your phone and your smartphone and your earphone, for example, and LTE or cellular or 5G. These are totally different things. And therefore, visible light communication is something completely or very different from LiFi. And I've just explained the difference. So VLC is primarily a cable replacement between two static entities, a transmitter and a receiver. For example, a data center where you have two racks and you connect the racks with a wireless connection, or the connection of docking stations to a wearable device. That could be done with visible light communication. You don't need multi-user access, and you don't need roaming support. And then there's another class of very important light communication technology. It's called optical camera communication, which is, I'll show you a little bit later. pureLiFi's history has a little bit of flavor of this as well. Optical camera communication uses the embedded CMOS sensors in a smartphone or any phone to receive data. So you can take pictures, but if you have a device that captures photons and the photons fluctuate, we have developed patented some technology in order to enable a camera to receive data at fairly high speeds. But it's one directional, and it's nothing to do with LiFi. And then we have the old technology of connecting things outdoors over long distances into the kilometer range. It's called free space optical communication. It's like microwave connections between one building and another building outdoors, and you can use the optical domain space as well. But again, different from LiFi. So talking about outdoors, I think there's one more thing that I want to highlight in that context, is when people say LiFi works well indoors when there is no ambient light. So it works basically in darkness. So what happens if you have strong ambient light? Would it work in sunlight? And I think this is some experimental setup from our labs. My standard joke is we had to wait 2 years in Scotland to get sun. Today would be a nice day to do this measurement. So we basically took a mirror and collected all the sunlight we could get in Scotland, in Edinburgh. You see that bright spot, this is the receiver. And then you have a micro LED of one of our collaborators in Strathclyde, Martin Dawson, Professor Dawson, has given this to us as an experimental device. So we have a LiFi link, a visible light communication link to that receiver. And we have about 50,000 lux receive power, and the communication link is still working. And I've summarized that with a slightly technical table here. The column shows you the different scenarios. The dark room, we looked into a dark room, a sunlight room with full irradiance. And then, since our data carrying photons are blue, we added a blue filter in order to then extract only the useful photons. That took a bit of away some noise. But the important thing is the row, the third one, where we show the data rate. The reference point, the data rate, is in a dark room. It's 1139.26 megabit per second, so above 1 gigabit per second, in a completely dark room. And then we look into the room, the scenario with the blue filter. It drops to 1080 megabit, so it drops by 5.18%. And if you don't apply the filter, you see it drops by 10%. This is because obviously we would run into saturation. We need to make sure that that's not the case. And we do this with automatic gain control and some other means. But the modulation that we use is sort of robust against the constant sunlight that comes into the detector. And that's the patented modulation techniques we have developed are robust to ambient light. Now, I wanted to highlight that. So with that, I wanted to summarize the first part of my talk and showing you what LiFi is and what LiFi is not and what it could do. And what it could do is also summarized here is we see this world of connected lights as the nervous system of the future. And imagine that every of this light is a node that also has memory and computing. Bear this in mind. So now I would like to turn your attention a little bit to pureLiFi. I'd like to highlight a little bit, walk you through the history of pureLiFi. This is the first time I'm doing this, so it's a world's first in a sense. So if I'm a bit stumbly at that part, please forgive me. But I think I had to go into deep, not into deep minds, but in deep technical archives of my computer to dig out the very first sort of proof of concept demonstration we did 2004 not in the UK and in Germany at Jacobs University. Sorry, it was 2005. I got that number wrong. In 2005, we've had TI evaluation boards, and you see there's an audio check there. And that means that there is a transition from a digital signal to an analog signal. So we use the audio jack to produce analog signals that we then use to drive an LED. And you see that LED, that white LED at the bottom there, that was our transmitter. And the left bottom was our receiver. And we have built sort of a test platform with digital signal processing boards. What we do here is, the idea of using light for data communication has been old. Alexander Graham Bell had this photophone where he did that. But what we wanted to solve is getting high data rates through LEDs, so higher than your TV remote control, which works in the infrared. So we wanted to find out how can we get really high data rates through an LED. And what we did is we used a method that is well known in the radio communication space. It's called orthogonal frequency division multiplexing. And that has a particular disadvantage for radio communication. And since the way we modulate data on LEDs is fundamentally different to modeling or impressing data onto antennas, so we turned that disadvantage into an advantage to transmit data through lights. And we wanted to simply see, does the principal idea work? And in fact, it worked. And that was really, really exciting. And we got we thought there's a key to a kingdom, and we wanted to explore this further. You saw the team here. That is a picture from old ages, and you see my old team in Bremen there. And there's one particular guy I want to point out is the little man sort of in the middle with a brown jacket. This is Mostafa Afghani. He was an undergraduate student when we conducted that experiment, and he's now the CTO of pureLiFi. So I think people have, and that's also very important if you want to change the world. People need to buy into that vision, and I'm really delighted that we have a wonderful team to have taken this idea to where we are at the moment. And physics is very important to us, and there was a very important physics exhibition in Germany. It's called Welt der Wellen. this world of waves. And you see here another sort of former PhD student of mine, Hani Agala. He's now a professor in the United States on visible light communication. So we transmitted, for the first time, not videos, but you see the desk lamp there. We transmitted high density images through that desk lamp to that receiver at the desk. And we showed that the principle works. And that work was then discovered by the German government. They asked a former Nobel laureate, Professor Hensch, to go through the research labs in Germany and find out what could be the ideas that could transform our everyday lives. And he wrote a book, and it's still available at Amazon, 100 Produkte der Zukunft, where this light communication is seen as one of the transformative technologies for the next decades going forward. And that gave us a big boost. But that boost also came at a stage where I transitioned from Bremen to Edinburgh. So what I did then, you see the recurring pattern here. People have aged, but the team is similar. I went to Edinburgh and I applied because at that time I knew there's something in that technology. There's something that could be made out of it, and applied for a Scottish enterprise-funded proof of concept grant. They gave me some money, but they said, you can finish that, but you need to complete with a company. If you don't found a company afterwards, we take away the money. So with no pressure, we started to work on a project that we called Delight, where we developed a technology that you see here in this little video, here transmitting data, you see here, from a light and into a receiver. And this is sort of the ingredient, what later became a demonstrator, where we demonstrated this technology for the first time to the public in 2011, 2 years after the start of the Delight project. And I mean, Paul mentioned the TED talk. And if you look at it, there's a gray cabinet on stage on the red circle. And the gray cabinet here is green because it's not yet painted. But I think this is the first image of showing what's inside. And what is inside actually is a lot of standard stuff, such as power supplies. At the bottom, we have FPGA boards. We have an A to D and D to A board. They are very big. And we have there, you see that that silvery thing. This is the receiver and the analog circuitry to drive the receiver. In that case, you see that cable here from the D to A board running down to that gray box, and that was driving the LED. And the receiver was embedded roughly about here, so in a little tube within that gray box. I wanted to do that because the TED guys have said, you need to show that it works. And the way to show it is you put your hand on top of it, and it stopped transmitting the video. But that haunted us for a long, long time because people said, oh, it's line of sight technology. But we designed it to be line of sight so I can prove that we are using the light to transmit data. Having said that, LiFi is not only line of sight. It also works in non-line of sight situations. So that was the gray cabinet at TED Global. And that was at TED Global in 2011. We showed, you see the cabinet here is now gray, and you see the IKEA lamp that we put out, and we stripped out the halogen light, and you see an LED, and you see the same Osram LED light inside that lamp. And this is where we then transmit this video to the back of the screen. But we had very big sweating moments when we showed that because we had 20 minutes to build it up. Although we rehearsed 100 times, when I went on stage and Mustafa left the stage and people were streaming in, he said he was sweating. And he said to me, it may not work. And I said, oh, thank you. You just killed my career. And it was really shaky. The signal-to-noise ratio wasn't there. But the reason was, in a nutshell, is there was an artistic interlude after the talk, between the talks, and they played the air piano. Do you know what an air piano is? This is a piano with a bank of lasers. And depending on how high your hand is away from the laser, you change the tone. So you play the air piano like this. Lots of lasers, but lasers for this very early stage technology weren't very helpful because they brought in a lot of noise into the receiver, and that almost sort of broke that demonstration, but it worked. Quite happy. So this was 2011, and we started pure VLC in 2012 in January. And now the TED demonstrator, you see already the journey of miniaturization. The TED cabinet has become now a fairly sized, what we called pre-production prototype. So then we went out to customers and said, oh, here, you have this brick. Put it into your phone, and we are very happy. We license the technology to you. And they said, oh, it's a bit it's nice, but it's a bit big. So we thought, okay, how can we use existing infrastructures within a smartphone? And this is where our little excursus into optical camera communication played in. So we patented a technology where we exploited what is called the rolling shutter effect of a CMOS sensor. So a CMOS sensor, how it captures an image is scanning the scene line by line. And if you then turn on a light bulb in the same frequency as the scanning rate, you essentially see black and white stripes. And these black and white stripes are then sort of proportional to the data, to the on-off keyed signals you're transmitting through that. And we called that light message, and we thought this is our first product.
Here we demonstrate our light message application. We're going to send a light message from an LED light bulb to a standard smartphone. We start the light message app on the phone. Then we type a message which is encoded onto the signal used to drive an LED light bulb. We cannot see this signal within the illumination, but the app can. The phone is pointed at the illuminated area, and the app decodes the message contained within the light signal.
So we had a technology where we can transmit data to a phone, but the data rates were in the kilobits, so like your TV remote controls. We haven't really made that leap that we wanted to have into high-speed data communication. So we left at that stage, but we were delighted that others picked it up. If you go to Carrefour's in France, you see that Philips Lighting have provided that technology for indoor navigation using that principle. Sorry. So we then went back, and that's usually, I mean, the journey of our company. If people ask you, a company, is it always a want to finish one straight line? And this is an example. It's not a straight line. So we did a little bit of a wiggling here, but then we went back to the road of high-speed bi-directional connectivity and networking. So you see the years, and that 2001 should be 2013 with our first system, what's called the LiFi. It had 10 megabit, the same as the TED demonstrator. So we've taken that pre-production prototype and put it into that box. We then moved on and said, okay, that first box wasn't really mobile. It wasn't really integratable. So we went to that, what we called LiFlame, and had a dongle. That first bit here, that was our first dongle. And the width was about 30 centimeters. You put it at the back of your laptop and then you could be connected. But it's what was the first networking device that supported multiple users. We integrated it into a first dongle in 2015-16, what's called the LiFi X. This dongle here was the first not battery-powered, USB-powered dongle with a receiver. You see the blue filter and the infrared LED. And then took that technology further to integrate it into a very small dongle, 2017, that had the weight of 40 grams and has 4 times the reduction of the LiFi X, but the data rate was still stable. So we focused on miniaturization. So primarily looking at beachhead markets like defense and security, where data rate wasn't really that critical, but it was sort of small and secure. And then we've taken 2018 the dongle and integrated the digital baseband into a chip. That's 2018 is the world's first LiFi microchip that we demonstrated, and this chip is already in products with customers and partners. But the data rate you see now, the miniaturization goes on, but we at the same time have now started our journey of increasing data rates. So the chip already moved by about 50% to 67 megabit per second. But if you followed Mobile World Congress this year, we have now further miniaturized, and I show you that thing that is integratable into a phone is here. For those who have very sharp hawk's eyes, you may see it, a very small device that we integrated into a laptop, and we showed downlink transmission speeds of 1 gigabit per second. So we have about 20 times improvement in data rate and further reduce the size. And this has now brought us into a space that we have a technology that is mass market product integratable. So this thing there on the left was our TED cabinet, 10 megabit, and it had to be transported with a van in 2011. And this is the device that I showed here, which I have to make sure that I don't lose it, because Alistair Banham, the CEO of pureLiFi, would kill me if I lose this prototype. So it's very small. We can integrate it into smartphones. So that is where we are. And here's a screenshot of the data rates that are currently achievable. You see more than 1 gigabit in the downlink and in about 600 megabit in the uplink. And also, again, a little video from Mostafa here. You may see he has changed a little bit since.
Hi, I'm Mostafa Afghani, CTO and co-founder of pureLiFi, and here we have our prototype of a gigabit Li-Fi system. So we've launched the first bespoke Li-Fi components to deliver gigabit Li-Fi. These have been optimized for footprint, power, and really push performance. As you can see here, they're really small, and the components themselves are small enough to be integratable inside a handset. Here I have a very simple demo which will show the link rate between this laptop and another that's in the cabinet. So let's start. And we see that the downlink line rate is just over a gigabit with an uplink of 425 megabits.
So this was February this year. And I can give you good news. This is only the start of a long journey, I believe, because we continue miniaturizing and we continue increasing the data rate. And remember, 1,000 times more bandwidth than the radio spectrum to be exploited. So, I mean, after I had the TED demonstration and we showed it to the public, there was huge interest worldwide. So the question is, there's still huge interest. So what is the fuss about all of this Li-Fi technology? Is it about data rate? Obviously, it is about data rate, because in order to make our future wireless communications future-proof, we need pipes. We need data pipes, many secure data pipes. But that's not the end of the story. We also want to ensure that we provide quality of service. If you put on your water tap at home, you expect that at any given time, there's enough clean water that's coming out of it. And wireless connectivity is a utility like gas and water. So when you turn on your Wi-Fi, you expect you get what is on the tin. But if you run speed tests, sometimes you don't get what's on the tin. Especially if you go to a basement, if you go into some areas of your home, it wouldn't work. Especially if you then have a family where you have a son playing Xbox and so on, the share of bandwidth you get is reduced, because many items and many people want to use share of that radio bandwidth. So you get only a fraction. And the more users we have, the smaller the fractions become that you get on your phone. So quality of service is one important parameter as well. And that also translates into data rate per area, not only data rate per link, data rate per area, and that's very important. So if you want to talk about machine type communication, and you want to take sort of autonomous cars, and they're driving, and you want to make sure that you're not crashing in the car in front of you, so you need a very fast reaction time between these autonomous vehicles, also drones. So latency becomes a very crucial parameter and quality parameter for machine type communication, Industry 4.0. That's very important. And then lastly, and perhaps most importantly, security is important to ensure that no one can eavesdrop, to ensure that no one can turn a car on the road into a weapon by intercepting into its nervous system, i.e. into its wireless connection, so it has to be secure. So these are very important parameters we must and will not and have not forgotten. So here's that expressed in numbers is that surveys done, you see all the reference at the bottom, that first of all, that almost 90% of users want faster connections. That is against the general belief is, yeah, Wi-Fi works. Yeah, it works. My bike works as well, but if I want to drive from London to Edinburgh with a bike, it's a bit hard call. So you need to be faster. And then the last point is the survey says 71% of users are not so much worried about the data rate, but more about speed, about coverage, and about the general experience with your wireless technology, that you really get the data rate you're promised to get. So that's about the user experience, but it's more than data rate, it's experience, but it's also security. You want to have privacy. You want to make sure that no one eavesdrops and that you are not also reading data from others. The way Wi-Fi works at the moment is radio penetrates or moves through walls. That's the nature of radio waves. So that's why expressed in the red circle, you have radio waves that basically cross rooms. If you have light waves stop at opaque objects like an opaque wall will stop. So no one in that neighboring room will be able to read any of the data you're transmitting in the right-handed room. So it's completely secure. And that is one of the principles we use, but there are more principles that we can use, because with LiFi, we can also determine if we have the MoFi hold the handheld in this way, in that way, or that way. Or we can also make sure that if I move here across the lighting network, the lights would record where I am and what location, so I can combine that with location data and have sort of data analytics on top of communication, so providing usage patterns and adding sort of knowledge to what is called machine learning in the future in secure networks. So that is really a space that is also enabled by LiFi. The property that LiFi stops at a wall is not only used to enhance security. Imagine you have a situation like this, a very crowded, tense deployment of rooms and flats in a high-rising building where every sort of tenant has its own Wi-Fi box, and the Wi-Fi signals go through the walls. You create a massive mix of interference, of radio signals. You see that red circles? So red propagates in all rooms. So you get a massive interference, and if you don't carefully manage your channels in Wi-Fi, you get a significant reduction because of interference between Wi-Fi access points. Now, if the same situation with LiFi, there is zero interference because walls would block the light signal. So you could A, be more secure, and B, higher data rate, higher area spectral efficiency, because there's no interference. So we have two birds with one stone, if that is the right phrase. So we have very big advantages here that we can exploit. That fact that light is controllable by walls, but also by the shape of the light beam, can be utilized in a way to enhance this quality of service by providing higher area data density. To explain that, again, I've shown here on the left a typical deployment of a Wi-Fi system in an office building. You may have two Wi-Fi access points in each corner, and the red circles show you what is the coverage. What you see is three basic regions. One is directly under the access point, the Wi-Fi access point, you get good signals, good coverage, high data rate, maybe the data rate that is written on the box. Then you have areas where the signal has decayed quite heavily, and you get these dark black spots where you have no connectivity, you don't see any Wi-Fi signal. And then you have these areas where the Wi-Fi signals overlap, the area of interference, where interference reduces data rate quite dramatically. So therefore, you get this sort of very bumpy behavior of data rates. Now look at the same scenario with light bulbs and lights like here, where every light serves a certain area, very confined, and you get these nice coverage areas. You can argue there's a bit of degradation here, but in real world, there's no real white spots because light systems are designed so they provide uniform illumination. So that means if you take your light and send data here, there is zero interference to a user in that region. So if you have a certain bandwidth, say a gigabit here, then you would have another gigabit here, another gigabit here, another gigabit here, and there's no interference. So if say, for sake of the argument, you have a 5 gigabit per second per Wi-Fi router here, you have 2 routers, in that room, in that area, you get 10 gigabit per second. Now let's, for the sake of comparison, say this is only 1 gigabit per second, and you have 20 of them, you have 20 gigabit in that area, and it's very nicely sort of distributed to the users, and that's why you can enhance data rate and experience. So that is one key asset and one key advantage. The other one is as well the offload. We have seen in radio communications, when you take your smartphone, you get a typical data rate of maybe 5 megabit per second. And that is not because cellular communications have suddenly been so excitingly high performing. This is because a lot of your data transmission is handed off from cellular to Wi-Fi. So we call it offload. So all the capacity overflow is flowing off into Wi-Fi. It's a pressure valve in a sense. Now what LiFi can do is it can provide the pressure valve for Wi-Fi. So if Wi-Fi is overcrowded, we can hand that traffic off into LiFi systems. So it works alongside radio and it doesn't replace radio. That's what I want to say here. And also, given the 1,000 lanes, we have a very scary picture here of someone wearing the future AR, VR glasses. Is that, do you know why this is so big? Do you know why this is such a big, chunky piece of brick in front of your eyes? First of all, you have very high resolution displays. And secondly is that you don't want to be seasick. So if you move, the images should follow your movement quite in a way your visual system does. If that incurs a delay, you basically get seasick. That is why all the rendering, the image rendering, has to happen very close to your own visual system, to your eyes. And that's why all the computing happens in front of your eyes. There's lots of computers in there that do the signal processing. And that's why it's a big computer in front of your eyes. But we want to get rid of that. We want to have the same glasses that we have now, very thin clients. But to do that, we need to replace the computer and move the computing into the lights. As I said earlier, the lights will have computing power. Imagine this light here does all the rendering. And I only get data link, so the nervous system, to my thin client, and then I can have the experience of AR, VR in a natural way. But to do that, for example, if you get low quality images, we already need 210 megabit per second for our VR, AR displays. Medium quality, we ramp it up to 1.2 gigabit. Our current system actually could carry that load already, as I've shown. But if we want to have super good quality, we need a data link from our ceiling light to the thin client of 14 gigabit per second. There's no Wi-Fi system that could deliver that. But in our research lab, which is underpinning some of the work we see commercially, we have shown with off-the-shelf LEDs 15.6 gigabit over 1.6 meter already. So the capability is there, the technology is there, and we'll be able to achieve these high data rates with light. So this is LiFi will enable AR, VR, but not only that. Also, TV is going through a transition from 4K to 8K to maybe 16K TV, and these numbers will be skyrocketing, and you need connectivity for that. So it's a necessary component. Connectivity is a necessary component for future sort of smart worlds. And then automotive. I mean, this is a trend that we go into this machine type communication. Autonomous cars, drones, they need to be connected in order to enable autonomous driving, autonomous manufacturing, and Industry 4.0. As I said earlier, all the arms of a robot, they need to be controlled, they get different data sets, and we're working with in the aeronautics industry where every screw in an airplane has to have its own bespoke torque, and that's why you need a lot of data sets that need to be sent to the tools in order to make sure that the manufacturing is done in the right way, and also in an efficient way and in a productive way. And that's why these systems will support and help that. So this is the story about the pureLiFi and where we are. So now tell you a little bit about the progress we have made. And it's what I said earlier. It is important that these things don't work alone. And we have in Edinburgh a company, pureLiFi, that's full of shining lights. And we have sales in North America, in Asia, and we are driving the adoption of Li-Fi through very sort of selected partnership projects. We have partners in the mobile phone industry, we have partners in the lighting industry, we have partners in the security industry. So we carefully select these partners, and some of them are actually shown here in the next slide. We have deployments of our proof of concept prototypes and pilots in 23 countries, and we have over 100, in fact 133 current running deployments of Li-Fi use cases around the planet. And the use cases we have support, as I showed earlier, they vary. We have 20 use cases ranging from industry environments, health, security, and also sort of high-speed connectivity. And you see some of the names we are working with and have worked with around the globe. So the use cases I mentioned 20 use cases, and here I want to dive a little bit deeper into what these use cases are. And they are, with the perhaps a rate of adoption from left to right, there's a very important use case in the defense and security industry, and we have run a project in that space, and we have equipped an operational theater that you see in the left corner there with Wi-Fi and with Li-Fi, with some of the partners, and have done some experiments where it was shown that Wi-Fi was detected in a flick of a second in that operational theater. The 10 Li-Fi units we had installed there, and the signals coming from them were not detectable. So because the opaque cover of a tent will not let Li-Fi out of the tent. And that provides a very secure environment to transmit data wirelessly, allows rapid deployment, and so on. Data center environments I've shown earlier, we have also the Industry 4.0, but unlike radio communication, it also works underwater. So we can also use it for underwater mission. And this is increasingly becoming important because we do want to understand more about what's going on underwater. And obviously in the office environment, allowing high-speed, secure, reliable communications. The retail and finance also for security reasons allows very secure transactions in combination with blockchain. That provides a very strong proposition. For the transport, so car to infrastructure, a lot of wonderful use cases in city environments, and then the smart home with the AR, VR, and so on, what I've tried to explore. These are the wonderful sort of application spaces that we can supply. And this was actually one of the biggest challenges that we had to narrow down the focus of the company of pureLiFi, because we had so many exciting opportunities. The question is, you stand within in the woods, which tree do you select? And that took a bit of time to find that out. So here are numbers of early adopters. So we have been working in the aeronautics industry for now 13 years, and we have built systems where we have turned reading lights into high-speed bidirectional communication devices. We have built backhaul systems where we help to reduce the weight of an aircraft by replacing cables with wireless connections. So that's all run and tested in pilots, and we will see that coming to market very, very soon. Then in health and security, where it is important to have sort of secure data. So you have delivery of data to the point of need, not when you want it, or when you have it, or you can have it, but delivering data when you need it. And that is when you require the location properties of light, where you have, for example, a scenario where you have store particular data in that operational theater, and you move away from that area, you get other sets of data stored in that local network, so that any data in that corner cannot be accessed anywhere in the hospital, so it's completely secure and safe and safely stored in a privacy secure manner. There's also techniques like geofencing, where we would allow access to access points in a certain area, but if you move out of that area, you would not be able to access certain sets of data that we call geofencing. It's not possible with radio, because radio scatters all over the place, and therefore you cannot have these islands of data, of controlled signal propagation as you have in light. So we work in the industry 4.0 defense sector with the Babcock, where we, as I said earlier, we deliver data to the point of need. When you move around in a factory and you want to measure some control information, telemetry data of a machine, you run past the machine and you get the data onto your tablet. And if you move away, then you get a different set of data. And that is possible in that environment. So we have a pilot there. There's also a few new adopters in the consumer use cases. One is where we were absolutely delighted. It's the deployment of LiFi in a first school in, I must say, in the United Kingdom, because there's a similar school equipped in Germany by some of our partners and collaborators. But in Scotland, we have equipped the Kyle Academy in Ayrshire with LiFi in that classroom. You see the Connectivity Minister of Scotland there inaugurating that system, where the laptops, you see here, the LiFi XC dongle sticking out here. Every laptop on every table was connected to the lighting units with that dongle, and we had 8 lights that we enabled with LiFi. And the connections worked flawlessly. But the interesting side effect of that installation was that the pupils in the neighboring room suddenly saw a rise of their Wi-Fi speeds. Suddenly they got maybe from 2 megabit, maybe 4 megabit, double the data rates. And the reason is we offloaded from Wi-Fi into LiFi. So all data transmission in that classroom was done by LiFi. So this room did not create any interference to the neighboring room. And therefore the neighboring rooms had a very benign environment signal-wise, no interference, no takeaway of bandwidth, woof, Wi-Fi lived. So LiFi helps live LiFi, if that is the right form of saying it, but LiFi helps Wi-Fi. That is very important. It works jointly together, and it provides these additional data pipes that we need. We have also in the consumer space a very exciting demonstration here in London, in Slough, with O2, where they equipped a room in a showroom in their head offices, and they want to ensure that they demonstrate sort of future-proof wireless connections within that organization, and they see O2 sees LiFi as one of these solutions that helps achieving that goal. So we are now ready to design in LiFi into devices, and again, this is the size of where we are at the moment. It's integratable. Whenever I give a talk, people come and say, "Great talk, great technology, but what about this? What about that?" I mean, there's a famous quote by, I think, Henry Ford, is, if I had asked people at that age what they want, they said, I wanted faster horses. It takes a leap to think into new dimensions, in new spaces. And I mean, I've just proven a point where visionary have had a great foresight like Tesla and Henry Ford. But I can also give you examples where great technologists got it completely wrong. And for me, Li-Fi is inevitable. I mean, like you're running out of water and you suddenly have basically an ocean of water in front of you. What would you do? Would you go away from the ocean, or would you take the ocean of water and turn it into drinking water? I think this is where we are. We are at that stage. And here's an example where I'd like to remind us that people can get it wrong. And if they, we leave it. So, I mean, you can read that. Is it true? If someone says, no, Li-Fi will never happen because, but, this is an example where this is wrong. Maybe, certainly in my view. But there's others that people said, oh, the television, there's no market for television. And where are we with television? I mean, how many TVs do you have in your personal space? The mobile phone, your TV at home, many. There's other examples in the people saying, oh, okay, I have Wi-Fi, Wi-Fi works, all fine, don't care, don't bother, give me peace. So these are the people that look at the 3.5-inch floppy drive. It worked, it still works. You could still put it in your computer, but loading sort of Fortnite, as my son would love to do, with these devices, I think I would have to extend my house to build storage for floppy drives. So, and then the 700 megabyte device came. Oh, great, but that's the end. We don't need more. And then we got the dongles, 1 gigabyte. And now we have 256 gigabyte on our smartphones. I mean, you can always say, it works, it's enough. But it is not. If we want to prosper, if we want to have a prospering society, if we don't want to be overtaken by other societies, we have to believe in technology because it helps us. 100 years ago, the average age was 50 years or so. Now it's over 80. It's because of technology, because we did that. So we have to believe in that. And the same is smartphones. The big smartphone, the big mobile phone companies 20 years ago, whom of which you may not see anymore, sadly, said, oh, why the hell do I need to integrate a camera into a phone? Why? There is enough cameras. This is a different market. This is a camera market. I'm a mobile phone manufacturer. What the hell do I do with that? Like the people say, light bulb. What the hell do you want to take this into a communication space? It's a light bulb. No, it is this made into this. And what we have now is more than 1 billion people around the planet have these small smartphones with cameras. And maybe don't have these devices anymore, but use the smartphone camera to send 1.2 trillion pictures around the globe and contributing to that 60% increase in data because they need to be saved somewhere and stored somewhere. So we need to be open-minded when we think about innovation, and it will happen. You can be part of the journey, you could be a supporter of the journey, or you could go back and rest in peace. I mean, it is mind-boggling. So I think I'm coming to the end of my talk. So we actually see a Li-Fi in every light bulb. And that means in every car, in every street light, in every smartphone, in every toaster, in every oven, in every shoe, in everywhere. And it will connect us. It will be the nervous system that enables the Industrial Revolution. And with that, I'd like to thank you for your attention.
Harold, thank you. That really was a great talk and a look to the future, but a look to a not too distant future, I would say. We're going to open it for question and answering, but we're going to invite Professor Hassi's colleagues from pureLiFi to join us. So Alistair Barnum, the CEO of pureLiFi and also guardian of the chip. I see you've taken it with you. And Sarah Skase, who's the Director of Marketing and Communications at pureLiFi. So Sarah, Alistair, and Harold, do you want to come and join me back on stage, and we'll take some question and answers. And I'll remind people who are on the live stream, if you want to tweet on hashtag IOP LiFi with any questions, we'll introduce those into the discussion if you tweet those to us. So while you take a moment, perhaps I could ask the audience, I'm sure you must have generated some questions from that. So any questions you'd like to put? So I'll work this way, if you bear with me for a second. So, sir.
You mentioned that you replaced a halogen bulb with an LED bulb for the uplink and downlink data. Why is that in particular? And also, if there's diffusers in these LED lights in the ceilings just for safety and optical safety,
Correct.
does that affect
Positively.
How are you getting with the audio at the back? It's a bit quiet. We've got some microphones. Perhaps if you could just repeat the question a bit.
So the question is,
just for the
we
online.
replaced the halogen bulb with an LED light bulb. Is that necessary? Is that correct?
Yeah.
And the second is the diffuser that we have in LEDs. Is that creating a problem?
Yes, yeah, we have it for optical safety, and
Yes.
it's going to be safe if we go with Li-Fi and the light is less diffuse or.
So we use the same light that we use for lighting. So all lights that you can buy are according to the British Eye Safety Standard, so they're all running according to that. And the reason why we use LEDs, these are solid state devices. So we could use an incandescent light bulb, but this is a string of wire that is heated up. Right. And if you want to change the intensity, you need to heat it up, cool it down, heat it up, cool it down, and that takes a long time. The time constants are high. That's why it's not so easy with incandescent light bulbs, and LEDs produce light sort of in a quantum way, in a sense. So solid state lighting with semiconductors, and then there's a different process of generating photons, and therefore you can change the intensity extremely rapidly. So it's a billion times per second is possible with that device. So that's why LEDs, and if you then move on into laser-based lighting, lasers could also be used. So all solid-state lighting devices can be used.
You might have preempted a later question on laser-based lighting, I think.
I wanted to do that, yes.
There's a microphone there, sir.
Richard Melville, Cellularity. We've met before, actually.
You did.
I was just wondering, your final slide was a huge panorama featuring thousands of different lights. Just wondered what the problem would be of interference between competing Li-Fi systems in a scenario like that.
So you're right. So if there are light cones that overlap, you create an interference region. But the interference region is usually very small. So then we can ensure that in that region we apply signal processing techniques that would resolve that interference so that users are served in a different way, maybe at different time slots. So we prevent that interference to degrade significantly the speed. But the areas of overlap are usually very small and deterministic. So we can control that much better.
You could even look up. So lighting designers are quite naturally good Li-Fi network designers. If you look up here, you can see on the ceiling it's like a perfect Li-Fi network just above you.
Okay, thank you.
There's a question just behind you.
Hello, I'm getting down at the rather more basic end, I think. I was just wondering about whether the coverage down has to have the same area as the coverage up, whether you could have a situation as you've had in the old DSL days where there are different data rates in different directions, and perhaps you have a sensor in the ceiling which has a wide coverage but a narrow coverage going down to get high data rate feed to the mobile.
So you must have thought of that, because that's
I think, first of all, the links are completely independent. We could have, for example, a scenario where I have a detector here and it's pointing into that light source, and this light covers a wide area. So if I turn my mobile phone a little bit in that direction or in that direction, it will still receive the major part of the light from that light source. It probably will be served by this light bulb. But if I have a more narrow beam in the uplink and I move it like this, and suddenly the transmitter points into that light source there, and it provides me a better signal-to-noise ratio there, this light bulb will pick up the uplink, and then it will be behind the ceiling in the networking will then be combined. So it can be operated as completely different links, and the optical systems can also be independent.
There was a question at the back, and then I'll work my way over a few questions over this side, but there was one at the back. Yeah, thanks.
Does the color temperature bear any difference on this as well?
Not really, because we can basically use every wavelength, and the color temperature is linked to that. And the way we build these gigabit, and also we have started a research project looking into terabit optical wireless systems. Basically what we do is we narrow down the spectral emission more and more, and have sort of what we call wavelength division multiplexing, using narrow spectral bands to transmit in parallel. So this is part of the entire sort of way of scaling up the data rates.
I'll keep working across if I can. I will come back to
Hi.
the front if that's
Sorry.
Yeah.
My name's Nigel Parry. I'm glad to see you included streetlights and smart city in there. And I remember you doing a talk in 2012 for the ILP when our Li-Fi kicked off. I've got so many questions, but I'll try and condense them into one. I mean, in simple terms, we're a LED streetlight manufacturer. How do we fit it? Because we'd be more than happy to fit it. But that leads into other questions about connectivity between the street lights, and then also interference on the street. Because if you've got a busy street, such as the one out here, you've got shop lights, advertising lights, street lights. Does it, have that interference aspect again?
I can answer the interference, but Alistair, do you want to take the first question with the street lights?
Well, can we adopt or use street lights for light fidelity? The answer is yes. We know it does work outdoors, and it needs to be implemented in a controlled way in terms of the beam and the angle, and you obviously need the right backhaul to drive it as well.
So in the interference question is, you could also ask what happens if you have a foliage, you have leaves that reflect the light into a receiver, and it also creates sort of kind of flicker, as you said, with the reflections. But these are rates far below the modulation rate at which we modulate. So the lowest frequency that we use to encode data is 1 megahertz. And your computer screen is 100 hertz. So even the flicker coming out of your screen, or the flicker coming out of fluorescent or other sort of lights in the 100 hertz and greater, this is completely filtered out. There's no effect. And as Alistair said, we can control the light beams in such a way that there's no interference, because light can be controlled. In fact, you can see where interference is. And that's something you can't do with radio.
I mean, just to add to that, I think the pureLiFi kind of vision at the moment is, we know that 90% of data communication is going to be indoors. So our initial focus in terms of our strategy is clearly to enable the indoor environment. But also we do know from work we've done externally that we can use Li-Fi in lamps and other environments outside. But our main focus while we're developing these integrated devices is to ensure we can get into the devices to enable a better experience in the home. So as we know, with all the number of multiplying connected devices that we have in our home, and you probably know yourself, there's TV, multiple handsets, gaming equipment, everything is Wi-Fi driven. We know that is going to increase substantially, and so our strategy is really to provide improved quality of service through our technology into the device manufacturers, enable us at home to have a much more improved quality of service. So 90% of data will be transmitted indoors, and that's really where we're focusing our time and effort to improve that experience.
Just next to you.
Hi, Chris Hickling from a company called Connectix. I've got a lot of questions, but I'll only ask sort of 1.5. These lamps obviously need power, and they're going to be providing data. So are we looking at some sort of copper connection to these lamps, like a power over Ethernet connection? Like you can have powered LED lamps now. And if that's the case, you had a slide that talked about 14 gigabits per second. How are we going to get 14 gigabits per second over a copper cable to a lamp?
So I'll let Sarah and Alistair answer that, but I also showed you a slide with an aircraft where we had a wireless backhaul. And with that, I didn't show the data rate, but we are deploying 20 gigabit through the system at the moment. It's a meshed network, meshed optical wireless network in a point-to-point fashion, but it's not LiFi, it's basically VOC or FSO in an aircraft. So optical wireless is a solution there as well. But if you go to lower data rates, I mean, there's power over Ethernet, giving you gigabits of data rates, or power line communication, which is not the preferred technology, but for retrofits, it's a good solution. To new installations, you use power over Ethernet. Yeah. So again, there's a similar technology roadmap as we have with our technology, and they are very nicely aligned. I don't know if Sarah, you have looked at this quite a lot.
Yeah, well, you covered it. So typically with our customers, many of them use power over Ethernet, but as you said, when we drive speeds forwards, you've already proven that backhaul can be done with VLC.
Mm-hmm. Yeah, and what we do is, so we have power over Ethernet or PLC with our systems of data, enable customers to demonstrate and check out use cases using communication via light. And what we do is we work with partners, and we have some partners out there now that we're developing our technology integrated into these luminaires, downlights, panel lights, where you take the driver, you integrate the LiFi technology with that driver, and then it's powered by a straightforward power of Ethernet cable. Or you can add it to the PLC system as well. They're very versatile.
Question at the front here. Thanks for hanging on. Mike's just on its way, and then I'll come back to you over here. Thank you for hanging on. There you go.
Has there been any research into the biological effects of LiFi?
I think I mean, Edinburgh, we have very good neuroscientists in Edinburgh, and I wanted to understand very early on in 2011 the impact on flicker and on epilepsy and so on. And I said, can we have a look into this in a cross-disciplinary research project? And he asked me, so how big is your flicker? So what flicker rates are you talking about? You know, one gigabit, very low. And he said, oh, I'm not interested, because everything above 5 milliseconds is sort of how the physiological systems operate, will have no effect. So I have no scientific interest. So that's why that collaboration didn't start. So I didn't do any work in that. And others have. And my colleague, Vasily Popula, actually did some EPSRC funded research project, and he found no issues with that. But that's only one piece of work. But there may be others. Sarah, you have looked into this as well.
Yeah, well, pureLiFi doesn't invest in research on
I think that's important. But another question, if I may, is can you foresee a time when LiFi replaces all RF?
No, we don't hope, and we don't think it will ever replace all RF, because radio, if you go hiking, I love the Highlands, if you go hiking and you go up the hill and want to talk to your wife or whatever, want to communicate, you won't find probably light bulbs distributed on a pathway to the Highlands. So there's radio still needed there for the long range. There's radio needed outdoors. And radio is a proven, established, well-functioning technology that has served us very well. No, but we are running now out of bandwidth. And what we do is we add bandwidth.
But there are significant health effects from RF. And there are plenty of studies about that. So I was really hoping that LiFi would actually be a good alternative.
I mean, we cannot comment on LiFi versus radio and health effects. But what we say is LiFi provides thick data pipes that are free and license-free and unlicensed. And we have not seen any issues around health of flickering lights and flickering at these very high data rates, where we have monitors that flicker at 100 hertz and more, and sitting in front of them every day. I mean, yeah, a radio is a technology. And again, it comes to the point that I make is we often dismiss our technological innovations. And the reason why our working environments have changed, why we can work at home, we can work while we transit from A to B, is because we can be wirelessly connected with radio. So it has done wonderful things. But what we want to do is we want to add and make sure that wireless communications is future-proof, and we add to radio communications.
So can I just add to that? I think we're complementing additive. I mean, you put it into your mobile device. You put your mobile device into your pocket. Well, light doesn't pass through my pocket, so it needs to transfer to another protocol to get the data. So we always see, an interoperability with the Li-Fi and other radio standards. So you always access the data wherever you happen to have your device. So whether it's out in the open, then it can pick up the lights, goes in your pocket, then it will switch over to an RF.
Just think of your phone. So you use 2G and 3G still, and you use 4G. Hopefully soon you use 5G, but then also you'll use Li-Fi, and you'll just use that when you need high bandwidth communications.
And it helps in a sense, as Alistair said, 90% of the traffic is originating indoors. And if you use radio and you have to send the radio through the walls to the base station outside, I mean, that may not be good in terms of training your battery, but also maybe too high power. When you have lights around you that have a very short link and provide you with high speed and even higher data rates with there, it's a natural fit. And we just have to work that out.
There's a group of questions in here which I'll come to now, and there's a few over here I'll come back to, but I might go to the Twitter feed in between if we've got anything. So on the aisle here, yes, thanks.
Well, I'm not quite sure if it's an appropriate question to ask here, but what is the advantage of pureLiFi compared to your competitors who are working with this technology?
So, we spend a lot of time trying to understand where our competitors are. There are competitors out there. We don't know what's in their kitchen, of course, so we don't know what they're cooking. But from what we see and what customers tell us, we're probably 18 to 24 months ahead. We know that we're the only providers of a solution that is 1 gigabit in very minute package that can now be integratable into devices. So we've done quite a bit of research, and we see other competitors, people like Signify, for example, the Philips spin-out, they're into Li-Fi. And they're all part of this standardization that we're working on in terms of the 802.11bb. But, my goal as running the company is we got to stay ahead. I'm pushing integration, increasing the performance, getting power down, making them small enough, making sure we get them into these mobile devices. So, I don't want to be sleeping. We're not going to be taking things for granted. We're going to be pushing those boundaries. And, with the work that Professor Haas and Mustafa and the team are doing, we are driving this whole integration and high-speed, low device, low market price cost devices, so it becomes pervasive in everything we have.
There's some questions over here, perhaps just in the red shirt first. You've been waiting a while, thank you, and then I'll just come behind you there.
But what I may need to add is as well, so far the evidence is we have always led the market. I mean, I think tell me if I'm wrong, but I think we were the first to bring out a dongle that is fully networked.
Yeah.
And only after we brought it out, others have brought out a dongle, following our model. And I think in many cases, we've really led the markets. And that is something that we continue to do.
And, and big global customers are coming to us. You saw the press release with Zumtobel the other week. You've seen the press release with O2. Wipro is a massive enterprise and lighting company in India is working with us in integration. I can talk about those because they're public. And there's a lot of others which we cannot speak about where we're working and engaging with customers. Why? Because they see us as the leader in the technology that can deliver solutions that help them solve their problems, which enable us to have a better experience in our daily lives.
My big concern is about security, which you haven't mentioned a thing about. You showed the map of how Wi-Fi and Li-Fi differed, and that it was more concentrated. But a glass window, you would see the light. And so therefore you could take data from outside the room, although you're concentrated within that cone which you showed. The other aspect, of course, if you have things like lampposts and so on, if you're speaking, who can tap into what you're saying on the street? Is this not a great danger that privacy will just disappear completely?
So you mean you can add, first of all, with the interception through a window, you're absolutely right. You're not claiming it's 100% secure, but it's significantly more secure than radio. I'll give you one example. You may be able, with a telescope, maybe the size of a meter or so, and perhaps you will be very visible when you have such a big operational device on the streets, you may be able to focus on one point, maybe the light in the ceiling, but in order to intercept a connection on the MAC layer, you need to intercept both directions at the same time. You can't basically have, you need to have two telescopes and look into transmitter and receiver to intercept in the bidirectional communication link and in looking at the key exchanges. So that's one reason. It's fundamentally more difficult than in radio, because radio propagates in the same way, uplink and downlink. In a sense, you can intercept both channels, but you have two cones that are pointing to each other in a sense. That's fundamentally different. And also with light, you can contain it. You're right, if you're under a street light and you have your connection there, and you have a bidirectional connection under street light in a cafe, and only somebody in the same cone may intercept that connection, but that would be a person that would be in the region around you, in a space that you can see. So a person that would be next to you, essentially. It's not like in radio, where you have the classic example of Starbucks. Somebody rigs up a Wi-Fi access point in some sort of hidden place where you don't see it, but then you link into it and then you're eavesdropped. That is not possible with Li-Fi. So there's mechanisms that we can work out and use in order to enhance security dramatically. That's what we've shown. And also with a telescope, your signal-to-noise ratio will be substantially lower than the one for the link of interest. And that means that the secrecy capacity is fundamentally reduced. And this is what our research has shown, that the secrecy capacity is about 20 times higher than you could get with Wi-Fi. There's many indicators that you can show us that we can build more secure systems. But sorry, you wanted
just to reply to that very quickly. First of all, we have already technology that uses lasers, so that we can get the vibrations from window glass and record the conversations within rooms. So I don't see that recording it from this cone is any more difficult. And in the future, perhaps that technology will become widely available. The other thing is, obviously, you can place a bug in somewhere like a light cone or a light area. And that, again, you don't have to be actually present to actually detect that signal and obviously tap into it. But what I'm more worried about is that with this proliferation of devices, everything from toasters right the way through to streetlights, there are more areas where security can be compromised and where personal information can be compromised. And as a consequence, we are going to lose our privacy.
So you okay. Well, if you want to add to it, please do. You kind of answered it,
comment on the growth of connectivity, but in comparison, what we're saying is that Li-Fi can offer greater security over current options, such as RF.
There was a question just behind.
Hi, my name is Eddie Brady. Firstly, I'd like to say I'm completely convinced about sort of Li-Fi. So my question is, it's kind of two questions. I don't think you're going to be able to answer it, but I'd like just to get your kind of viewpoints on it.
No pressure,
so my first question is, when do you think Li-Fi will be built into mobile devices as a sort of standard? So, I can go into, I don't know, wherever in PC world and buy a product that's Li-Fi enabled. My second question is, who do you think will adopt it first? Is it likely to be Apple, or is it going to be Android? Or is it going to be Huawei?
I think
he wants to do the way.
Android has many devices, but yeah.
So we're currently taking part in standardization of LiFi under 802.11. So there currently a standard for LiFi is being ratified called 802.11bb, and we expect that to be ratified in 2021. And we do expect that to be the point of inflection for adoption within consumer devices. But in terms of who we're working with, I'm sure you would expect that we absolutely cannot comment. and we wouldn't be so bold as to make an assumption as to who it would be that would do it first, because we're willing to work with everyone.
But But what I would add to that is, you've seen the size of the device that Professor has showed you. So let's use our imagination on where that can be going and what we're doing with it.
So, last question.
John Bullock from the Light Review. Hello, Harold. I gave you a lift to Edinburgh Airport, didn't I? Yes. Speaking on behalf of the lighting design community, and the conversations around cones of light always worry me, because it's not good lighting design. Sorry, it's just not good lighting design. We've got a much greater variety of how we get light into space. I really want LiFi to work. I really, really do. But it's that interfacing between, if you like, imagine an office that's just lit with decorative light fixtures, lamps in shades, uplighters bouncing light off the ceiling, task lights on the desk, no downlights, no LED panels, none of the conventional stuff, but very, very good lighting design. Are we going to see any sort of any argument from you guys as to, well, you can't do that and have LiFi?
Actually, I've got a great anecdote for you.
Thank you.
We have a software engineer in our office who, for lack of a better way to say it, is maybe a bit too lazy to put his light in the ceiling. So what he does is he develops his LiFi software by just sticking his downlight and bouncing off the ceiling. So he works off reflections all day long. But also, at Mobile World Congress this year, we demonstrated that actually changing the color of light and sustaining a connection is something that we can do now with LiFi. So we could take our GU10, modified GU10 bulb out of our light, which was doing sort of white light, white blue light, and then we replace that with a warm white light, and we sustain connection. So as the technology matures, as we drive down miniaturization and up speed, we're also getting this a different range of color qualities that I'm sure lighting designers will be quite happy about.
There was two questions over this side which I want to come to, but I don't know, Nikki, whether there is anything from the live stream.
Yes, on the live stream. Well, the most asked question has just been asked, actually, which is when is it coming onto our phones? So we've dealt with that one. The other one was, what's the #1 biggest challenge that you have faced or are facing bringing LiFi into the world?
So for me, the biggest challenge is getting adoption. Getting it into the market, and you need to build the standards, and you need to build the small miniaturized devices to be integrated. I mean, as Professor Hess showed in his speech, the first box was pretty big, had to be delivered in a van. So the challenge of getting that integration, collecting photons, running 1 gig, 2 gig, 3 gig, and above in a very small integratable package has been significant. The other thing is getting adoption, because people talk about the lighting plus the handset. So that's why the advent of the 802.11 BB standard was born as a topic interest group back in 2016, I think. And now it's a task group, and we'll go through the ratification stage. So for me, the biggest challenge is we always want adoption to go quicker. Doesn't, it takes longer, but it's adoption time and getting these packages to collect the photons in a cost-effective package with the high functionality, ultra low power, low size, integratable has been the big challenge. And we're there now. We are there with that integratable package. And so we can get this integrated into mobile devices and light bulbs and whatever.
There's a question just at the back there.
Hiya. Can everybody hear me? Oh, yes, clear now. So this is a question just in regards to augmented reality. So I'm aware that there's a sort of slow to being adopted by the masses, primarily because of what you mentioned and how bulky some of these headsets are. I just wanted some clarity around what you mentioned about how sort of Li-Fi can help in terms of helping people to reduce the size of these devices. I don't know, you didn't have time to go into a lot of detail, but could you just provide some clarity on how that can help in regards to sort of shrinking that headpiece to make it smaller and hopefully be adopted by the masses?
Yeah, no, thank you. In a nutshell, the bulkiness becomes, because it's a lot of printed circuit boards and computers inside the glasses in order to process the images that you display for your eyes locally. If it would be transmitted from far away with long latencies, the images that your eye would see would be delayed, and you would be getting a seasickness effect. And in order to do the processing off-site, off the glasses, you need to have very low latency links, i.e. you need to have very short distances and have processing that allows you to not delay the packets you send. So the idea with Li-Fi is a very short distance between a light bulb and the glasses at home. So the speed of light is basically very low, and we have very good signal quality. We don't have very good communication links, and we have a lot of bandwidth available. That's why we can relatively easily provide data pipes in the region of 10 and 20 gigabit per second. And that means that the rendering, and it comes to my statement at the beginning, we need to see the light bulb as a neuron of a neural network that connects our world, where there is a processor inside, where the signal rendering happens, that there is memory inside, where the images or the videos you want to download to the glasses are stored, and then everything happens. So the big chunkiness is up in the ceiling, that the only thing that you have in front of you is a display in a connections, a photo detector in a transmitter, so that it directly transmits the images that it receives from the unit there, from the light bulb. And that's why we can get rid of all this bulkiness. Or we believe we can get rid of it. We haven't done it yet, but this is the pathway.
There's two questions on the aisle. I'll start the one behind first, just behind you is it first, and then I'll come to the forward one. Thank you.
Thank you. It's Leo Carrington. I was thinking of the overall ecosystem. Where do you see both the value and responsibility for development lying? Is it with owners of the IP, or is it with the luminaire manufacturers, the device manufacturers? How do you see this evolving?
Our vision for the company is to be a fabless semiconductor company. So we're going to provide the components to enable all those companies in the ecosystem, whether it be the operator or the router or the switch manufacturer or the device manufacturer or the tablet manufacturer, to design in our components to help provide Li-Fi to the world. So, we're not going to build systems. That's not our raison d'etre. We are developing components to enable the mass market adoption.
And just as a follow-up, have you seen interest from the big networking companies to try and build on the back of this, who have previously been working on Wi-Fi?
So what we have to do is an ecosystem. You've got the operators, you've got the routers and switches, you've got the luminaires and lighting manufacturers, then you've got the clients, whatever that may be. So what our team have been doing over the years since the company was founded is to evangelize Li-Fi into all areas within the ecosystem to enable people to understand what benefits and value it can bring, whilst we drive our roadmap down to provide the components. So to answer your question, we touch all parts of those elements of the ecosystem, ensure that people understand A, how it connects together, B, what our roadmap is and where we're going, and how we address the data speeds and all the things that will enable this Li-Fi technology to become pervasive and become part of our daily lives.
Thank you.
Just a question, just in front, yes.
Thank you very much. Franco Cacialli from UCL. I was wondering if you could tell us more about the physical limitations to the bandwidth which is achievable. You said that we need more and more. So is 100 gigabit per second enough, you think, or reachable? Or because there will be a physical limitation, of course, on the drivers, for example, solid state you talked about, etc. And related to this, if I may, of course, we have solid-state luminaires now based on inorganic semiconductors, but there are also, just at the horizon, organic semiconductors-based ones that are much slower. So do you see them as a threat, the adoption of those as a threat to Li-Fi? Thanks.
So the question about how much data would we need, I mean, this is the floppy and CD-ROM example. I think you see that the fiber, the core networks are increased in their capacity, and that tells you that we want to share more and more data, and we see that 1 gigabit is something that is state-of-the-art, 5G, but we see the need for a terabit terabit wireless communications in the future going ahead. That's why we have started a research project, a national strategic research project, looking at terabit communication wirelessly, because we know it will be needed, and we want to be the first to do that, and therefore this is very important that we achieve that. And the thing is, we have a plan how we can achieve that, because we have such a huge bandwidth. And I need to agree that at the moment we started off with 14 megabit and 10 megabit, and it's far away from this big claim of 1,000 times more bandwidth. And that the reason is that we've taken off-the-shelf LEDs, which are primarily a blue chip with a phosphor coating on top. And that broadens the spectrum, so we get sort of a phosphor converts a blue photon in a yellow one, and blue and yellow recombine into white. And that's the color temperature for question as well, linked to that. And that emission profile is very broad. It's not ideal. So we want to work also with lighting device producers to develop a more Li-Fi optimized light bulb that brings down the spectrum emission profile, and then we have multiple channels and so on. There's various ways that can be rolled out, but we have to start somewhere, and what we started is a great journey. And obviously there's big things that we need to do in order to unlock the full potential. And you asked about OLEDs. I mean, we've conducted research with OLEDs, and I think we in publication have a paper at the moment. It's not yet accepted, but we report 1 gigabit with an OLED. So there's also research in that space that drives the boundaries. And then laser-based lighting is the other wonderful sort of example where you have big opportunities in driving further data rates. So it is a start, and we must not forget, 20 years ago, no one had a Wi-Fi modem in anything. And now Wi-Fi is ubiquitous. You can't take it away, it's there. But we often forget that it is not too long that we didn't have it. So be patient, but be supportive. We will change the world with Li-Fi, there's no doubt.
And a quick answer to the lighting technology question about the evolution of the lighting systems themselves. Was your second question?
I think okay. But I just, one thing I want to add to that, my experience is if you provide a capability to customers, there are people within those customers who find ways of using it, right? So that's what we do. We don't define all the use cases and whatever, but we show a capability. And I tell you, all these customers are looking for something to differentiate themselves from their competitors. And there's people in there that go, I know what I can do with that 20 gigabits of data now, or that 10 gigabits or whatever it is. So, that's what it's about. Is the floppy disk versus the 1 gigabit, the 256 in the phone. I mean, it's you provide it there. People have got solutions, or they know how to use it, or know what to use it for.
I'm going to take a few closing questions because I need to bring it to a halt. So if you just bob your hand up if you want to ask a question, and we'll probably, because there's a few, I'll take them together in a couple of groups, and we'll answer them together. Nikki, anything else on the hashtag that you want to shout out? Okay, so there were 3 hands over here. If I can take all 3 questions, and then we'll answer those together, and then the 2 hands over here will take those questions, and then we'll close out. So,
hi, good evening. I was just wondering about more like a marketing talk. If you told already a kind of strategy or how to introduce this technology, because as you said before, when a new technology come up, people is quite scared of the new things. So if you have like an idea or a strategy to introduce the technologies, like kindly, and how would you do it?
So hold that thought a minute. We'll take the other two questions and then we'll take all three together. So introducing the new technology.
You were talking about taking LiFi capability up eventually to terabit type data rates. I'm just wondering which runs out first, the LiFi or the cable-based or the processing that is necessary and switching that's necessary to cope with this?
Yeah, good question. And there was a question at the front. So.
Thank you. Tony McKenzie, it's Invisible Healing International. I'm developing products which work on 850 nanometer invisible light. I've heard on this demonstration today that it won't work below 60 lux. So obviously I was wrong in the hopes that I might be able to integrate it with my products. Is that correct?
Okay, so could we take those three questions together?
So there's three very diverse questions there. Thank you for that. So the first one is, how do you bring a new technology to market, right? So when LiFi was, shared by Professor Haas to the world, people go, yeah, I can see what it does, but how do you get them to understand what it does? So we built systems, which is why we built the LiFi X, the LiFi XC, because you have to put some hardware in front of customers, potential customers, so they can play with it and they have use cases. So that's how we started, and we have, as I say, about 133 deployments of our hardware technology with global customers in all regions of the world where they are playing with that technology. They're looking at their use cases and they're saying to us, give me this, and now that will help me deploy it in larger volumes later. So that's how we take it to market, and it's about education. It's about all of the things like today, for example. We're probably people in here may not have heard a lot about LiFi, and there's others that really understand it a lot more. So you've got all the marketing, you've got the branding, you've got the promotion, you've got the systems, you've got seeing, touching, feeling, playing with the equipment, and then people start to understand how they can use it in their own environment. And we don't know all of the use cases because they don't always tell us, but the customers do know the use cases, and they know how they want to use this technology in combination with other technologies they may have, because 1 and 1 may be 11 in their differentiated product that they're developing. So that's the first question. The second question was on the what's going to run out the processor.
I can't answer that, but I think I know that there's huge progress on all ends with multi-core sort of processor technologies. There's enormous improvement on some coherent fiber optic communication and wavelength division multiplexing, OFDM. All these things made it into the fiber world as well. And there's terabit. I mean, they're closer to terabit links in the fibers, as you may appreciate. But I think we have to have work on all ends, and I believe we are focusing on the optical wireless end and see a way to a terabit. But I can't say which one first.
I remember when I started in semiconductors, I think it was something like a 4-micron technology, a 2-inch wafer. You're now 8 nanometer, 12-inch wafer, and still going with billions of transistors on. So is it going to stop? You tell me. But I mean, we just know it progresses.
And the question at the front?
Was about the lux level, the lowest lux, 60 lux.
So where
you dim it. That was your question, right? How low can we go in terms of the operation of the LiFi technology?
Working on the fact that this system would be using photon rather than light. I mean, invisible light still uses photons and has been proven to have very beneficial health benefits.
So you use infrared.
Yeah, near infrared.
So do we. We can also use infrared to transmit data.
Yeah.
Sorry?
Yeah. We also use infrared to transmit data.
Yes, but it's invisible light.
Yeah.
So therefore, I take it won't transmit the signal.
No,
Yeah,
absolutely.
it does.
Yes, it does. So yeah.
It works in the. I mean, it works. We have even shown it in the ultraviolet.
Yes.
It works in ultraviolet. It works in the visible light. It works very well in the infrared. I think it's photons, and we also worked on very sensitive detector technologies called SPARTs, single photon avalanche diodes. It also requires very little light, and in fact, a SPART detects a single photon. So we are coming down to a quantum.
So, and one of the big questions we get is, well, what happens if I turn the light off?
Sorry?
One of the questions we get a lot is, well, we use invisible light technology. We turn the light off, what happens to it? We say, well, we have an infrared system in the downlink and the uplink, so you can work in the dark.
People use them for spotting animals in the forest.
Oh, yeah, well, that's, I don't know about that. That's heat
Let me
seeking
take
stuff.
two last questions. There was one at the back and one here, so we'll take those both together and then we'll close. So.
Hi, yeah, you've answered most of my questions already. This one's not directly about Li-Fi, it's more kind of imaginative, because you mentioned Alexander Graham Bell's invention. Could you imagine this technology being using sunlight again? Using sunlight, ever?
That's a good question to end on, and there's one at the back. I'll just catch the one at the back, but.
I don't know if I can quite follow that question, but my question is, this is clearly something that can have massive benefits to the whole of society. As the market leaders, would you agree that you perhaps have a social responsibility to ensure this benefits everybody, not just those who can afford the latest smartphone? And do you have any plans for that?
So again, two different but sort of related questions. So.
Really quick question. Yes, we want to have benefit everyone, and we have the Kyle Academy in Ayrshire is the first school in the UK where the pupils benefit from it.
Also 5G rule.
5G rule first is another example where we deployed it in the data-deprived area of the island of Orkney, where they really want more data, and we provided that. So we help the spectrum crunch as well. So we do that, but we can't do it on our own. We need support out here. And the other question is, yes,
can you use sunlight? That was the other question.
We theoretically, yes, because all we need is changing photons. And if we are able to change the reflected sunlight, then we could, but it's more a esoteric question, but it principally could be done.
Thank you. I think you've all earned a drink, definitely. If you would like to find out more about Li-Fi, there's some demonstrators upstairs. If we need to plug them into the chargers again now. But there's some demonstrators upstairs if you'd like to have a look at it if you haven't seen it. If you'd like to hear anything about the other demonstrator technologies in the building, catch one of the Institute staff team who would be more than happy to talk to you about that. But importantly, there's a drink waiting for you outside for those who are able to stay and carry on the conversations. Thank you to everyone who joined us on the live stream. And thank you everyone here for coming along today, making it such an interesting discussion. And particularly thank you to Harold, to Alistair, and to Sarah, the panel, for thank you. Refreshments just outside for those who can stay.
Thank you.